Hi, welcome back. Now, for today's lesson, we are going to continue with quadratic functions and we're going to explore minimum or maximum point. So, by the end of this lesson, you should be able to deduce the minimum or maximum point of a quadratic function after completing the square. But before we get into that, let us review quadratic functions. Looking on this function, f of x is equal to x squared plus 3x minus 3, we notice that a, which is the coefficient of the x squared, it is positive. So our graph will be a U-shape. Our roots, otherwise called the x-intercept, we read it from the graph. X is equal to negative 3 3¾ and x is also equal to 3/4. So that was read from the graph. Our y-intercept, written from the graph, it's negative 3. And our y-intercept can also be found in the function itself, which is just c. And this function will have a minimum point. Looking at another function, f of x is equal to negative x squared plus 3x plus 1. Or a, it's positive, so our graph will be an N shape. The roots, also called x-intercept, gotten from the graph is negative 1/2 and positive 3½. Y-intercept, where the graph cuts the y-axis, it's positive 2, or we can read it from the function itself, which is a number by itself, c, and that will be 2. And this graph has a maximum point. Then completing the square. That was in our previous video. To complete the square is to convert the function into a form that has a perfect square. So that was our main focus in the previous video. So a quick revision: identifier A, identifier B, identifier C. The formula for H is B divided by 2A, and the formula for K is C minus B squared divided by 4A. So maximum or minimum point. Question: the graph below represents the function, which is negative 2x squared minus 4x plus 3. You are supposed to identify whether the graph has a maximum point or a minimum point, and also you need to state the point. Now you do that from just the graph. Now looking on this function, our a is negative, so it will be an N-shaped graph. So you'll have a maximum point and a reading of the point. It will be negative 1, 5. Now looking on that same function, we are going to write the function as a perfect square, or with the perfect square in it. And we know what to do: identifier A, identifier B, identifier C, and then use these formulas. So these are the calculations of finding H and K using our A, B, and C. So K is 5 and H is positive 1. So our function in this form is there. Go back, yes, there. So f of x is equal to negative 2 open bracket x plus 1 close bracket squared plus 5. Now we are going to put everything together. So the function written with a perfect square is in it, it's there. The graph is there, and from the graph we know that we have a maximum point, sorry, which is negative 1, 5. Now looking on the form with the perfect square, we notice that 1 is there in the point and 1 there is actually h, and k is our y value. So we can conclude that h will be our x value, but the thing is with h, we have to change the sign. So if h is a positive 1, for the maximum or minimum value, it will be a negative 1. Or if it's a negative 5, the x value would be a positive 5. So whatever sign it is, it's the opposite sign in the maximum or minimum point. So, or concluding all of this, we have the function, we write it as a perfect square. The max or min point is negative h, comma, k. So our x value will be negative h. The y value will be k. And if you're asked for the maximum or minimum value, it will be the y value, which is the k. So these are yours to complete. Alright guys, see you next time.